Welcome to Module 2. In this module we'll be discussing basic geometry, and in order to do so there's some terms that I feel like we need to discuss. So in your notes I have a list of terms that we're going to be going through. The good news is for you that most of these terms you're just not going to be tested on. I'm not going to ask you, okay, what's the definition of this, what's the definition of that. I am more interested in, can you utilize these terms in more real-world applications. The definition is good to know and it's useful in helping us, but when we go to apply it, that's where I'm more interested in. So let's start with some easy terms. Let's start with plane, not as an airplane, but plane, P-L-A-N-E. The definition states it's an infinite 2D space. Alright, best way I know how to describe 2D space is like this whiteboard right here. It's flat. It has no depth to it whatsoever. I just have length and a width. Now, a plane is flat. It only has length and width, but it goes on forever. It just never stops. It just continues to go. And I know that's a hard concept to wrap our brains around, so I'm not going to talk about it anymore. Alright, now the next one. Point. It is a position on a plane. So my whiteboard is going to be my plane. So a point is simply a position on a plane. I have a dot, it's on my plane, this is a point. Now we can also name this point. Because I like it, I'm going to name it L. Hey L, how you doing? Alright, so that's my point. His name is L. Congratulations, you just met L. Alright, but since a plane goes on infinitely, a point, well, there's only one spot, but there's a lot of different points. So we have this guy. Well, I'm going to call him J. Hey Jay, how you doing? All right, so we got 2 points here. Okay, and we can have an infinite amount of points, but I don't feel like naming them all day. Now, a line. It says it is a straight path that passes through 2 or more points and continues infinitely. It doesn't end. So here are my 2 points. I'm going to make a line. Might be a little crooked, but it's a line that goes through them. Okay? This line goes through these 2 points, but it goes on infinitely. It goes on infinitely in this direction, and it goes on infinitely in this direction. All right? Ray is the part of a line that has a start and no end. All right, well, there we go. I just took my line and kind of stopped it a little bit. So it starts at J, it goes through L, and it just keeps going through the roof. That's what a ray is. It has a start and it has no end. Line segment is the part of a line that has a start and an end. Well, here's my 2 points. It starts at J, it ends at L. It doesn't go in either direction, it just stops there. Or we could reverse it and say it starts at L, ends at J. It doesn't really matter, it just depends on what direction you want to go. Alright, now these are some basic terms that lead us to something that's really more important that I'm interested in, and it's angles. So, angle. 2 rays connected by a common point. The distance between them is measured in degrees or radians. So we have 2 rays that are connected by a common point. It would look something like this. And we're going to name these points. And for the sake of time, we're just going to go A, B, C. So I have 2 rays. I have ray BA going all that direction. I have ray BC going all this direction. And together they have a common point, which is B. Which brings me to my next point. Vertex is the common point on which an angle or angles, notice I can make more angles, are formed. So these 2 rays are connected here. And so this guy is what we call the vertex. Now, we have an angle, but the question is, what do we call it? Well, we can give it a couple of different names, but it all depends on what points we're using. Okay? Well, this thing has points A, B, C. So we could call it angle A, B, C. Well, I don't like that one, so let's give it a different name. I could call it angle C, B, A. And then finally, I could call this thing angle B. All three of these names are correct. I could call it angle ABC, angle CBA, and angle B. Now, what do you notice that they have in common? B. If you are going to name an angle, you can name it just by the vertex, which is B, or you can name it by the 3 points, but make sure that the vertex is in the middle. Why? Because the vertex, if you look at it, is in between these two. It's in the middle. That's why it's so important to know what the vertex is. So let's change this ever so slightly. I'm going to erase that. So my question to you is, how many angles do you see? Well, you might see 2, you might see 1, but let's look at it. All right, so first one. We know that this one, and this one are at 1. So we can say angle ABC from here to here. That's an angle. All right, what other angles do we see? Well, I see one here. I'll use long dashes this time. That's angle ABD. So that's our first angle is ABC. Our second angle is angle ABD. Do we have any more? Yes. It's the out angle right here. And I'm just going to draw a solid line just kind of showing it. Okay? Angle DBC. Now, there were 3 angles in this picture that I drew. So I'm going to erase this so it's not too terribly confusing and just go back to the original angles. So we have 3 angles in this thing. What do they all have in common? The vertex. So if you told me that there were 3 angles and you just said that they all are angle B, you would be incorrect. Why? Well, angle B could be any of these 3. You need to be specific. Think about it this way. My name is Lewis. My last name is Lewis. So you wouldn't just say, hey, Lewis, when you have a room full of Lewises in a classroom. You're going to be more specific and say, call me by my first name. Hey, Jonathan Lewis. That way, I know who you're talking to. Same principle. The vertex is kind of like the angle's last name. You don't just always call it by, hey, B. You need to call it by its full name sometimes. Now, earlier I told you that when we look at angles, we also look at the distance between the 2 sides of that angle. And we usually do that through measurements of, like through protractors, computers, etc., blah, 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 blah. It doesn't really matter. And we find out that there's 2 ways that we can do it. One is we can get a measurement in degrees, which is probably what you're used to. And the other one is what we call radians. We'll talk more about radians later on in the semester, but not right now. So let's get things simple. So for the sake of argument, we could say that this was 35 degrees. Okay, that's pretty straightforward. Now, there's some special types of triangles that are based upon how many degrees are in that triangle. So I'm going to show those to you on the board right now, so you should see them. So the first one is a right angle. A right angle is essentially where the 2 sides are 90 degrees apart. Okay? This is a very important angle. It's almost where just about everything that we will be doing is based upon how this angle works. The next one is what we call a straight angle. Let's just call it a line. A straight angle and a line are the same thing. And a straight angle has 180 degrees. Okay? The next one is an acute angle. It's an angle that has less than 90 degrees. Think back to probably when you were in elementary. Your teacher said, just to say, oh, you know how you can tell it's an acute angle because it's so tiny and so cute. If that helps you remember it, fine, okay? Acute angle is less than 90 degrees. Now, an obtuse angle is more than 90 degrees, so it's like, your teacher probably did that. Well, my teacher did anyway. I don't know what they were doing. Extracurricular activities at home, I guess, is probably why they could do some weird stuff. But anyway, obtuse angle is bigger than 90 degrees. Maybe you'll remember that. I don't know. All right, so obtuse angle bigger than 90 degrees. I'm going to pause the video right here. I forgot to mention when I was recording this lesson, not only is obtuse angle bigger than 90 degrees, but it's also less than 180 degrees. So it's bigger than a right angle, but smaller than a straight angle. Okay, back to the video. All right, the next two big things are perpendicular. All right, so in this picture you see two lines are crossing and they make a 90-degree intersection. Makes sense? Just basically think of it like at an intersection with four stop signs. Excuse me, stutter. Now, the last one would be parallel. And parallel is basically when two lines never cross. Next in your notes, we have some special angles that I really want you to understand. And these angles are more like rules and how things work together. So up on your board, we're going to talk about first what's called supplementary angles. Basically, a supplementary angle is when I take two angles together and when they add up to 180 degrees. So in this one that we've got up on the board, I have two angles that we see. I have angle ABD, so that would be this guy right here, all right? And then I have angle DBC, which would be this guy right here. Now, for the sake of argument, let's just say that ABD is worth 135 degrees. Well, we know that these two are supplementary angles. So if angle ABD is 135 degrees, how do we find what BDC is? Well, we simply subtract. What's 180 minus 135? And we get 180 minus 135. We know how to do this. Will become a 10. That's a 5. That's a 4. Those go away. So we find out that this is 45 degrees. So angle ABD is 135 and its supplement is angle DBC, which is 45 degrees. Our next one that we're going to talk about is complementary angles. Complementary angles are basically when two angles add up to 90 degrees, where supplementary is 180, complementary is 90 degrees. So here we have two angles, okay? We know that when we add these angles together, which happen to be ABD and DBC, when they're combined, we get a 90-degree angle, which is shown right here. So let's say for the sake of argument that we know that angle ABD happens to be, let's say 36 degrees. My question to you is, what is angle DBC? All right, so angle ABD is equal to 36. We're trying to find DBC. How do we go about doing that? Since we know that these are complementary, we simply subtract the 36 from the 90. So 90 minus 36. This goes to 8, this becomes a 10, this is a 4, this right here becomes a 5, so 54 degrees. 36 plus 54 does equal 90. So, complementary angles are when two angles add up to 90 degrees. Our next two angles are what we call adjacent angles and vertical angles. Now, adjacent angles are simply this. They're when two angles share a common side. So we see two angles, BAC and CAD. However, they have a common side of AC. All right, that's all an adjacent angle is. They share a common side. Now, vertical angles, I'm going to give you the definition here, occurs when two lines cross to form equal angles on opposite sides of the point of the intersection, which is the common vertex. Long story short, you have two lines, they've crossed one another. Where they cross, this is our vertex. Okay? All right? This is why we call them vertical angles, not because they're vertical of one another, but because they share the same vertex. Whereas an adjacent, they share the same side and the vertex actually. This one, they just share the same vertex. On top of that, here's the cool part. If you know something to be a vertical angle like this, if you know that from here to here is 130 degrees, you also know that it's just directly below it, or whatever it's pointing to, is also 130 degrees. Basically, think of it like this. If it's 130 degrees here, its mirror image is also 130 degrees. Well, let's go ahead and use our rules dealing with supplementary. We know this is a line, so if from here to here is 130, what do we know this to be? We know it to be 50 degrees. Why? Because 180 minus 130 is 50. Well, if this is 50 degrees, we can use the rules of vertical angles and say, hey, its mirror is also 50 degrees. This one key concept with vertical angles, if you can grasp this, it is going to save your life in this class. The next big concept is called transversal. The definition states a line that crosses two or more parallel lines. So in my picture here, I have two parallel lines. I have this one and this one. And a third line is cutting through both of them. This is what we call a transversal. It's basically transversing the two parallel lines. Think of it from that standpoint. This leads us to our next three types of definitions. One's called corresponding angles, alternate interior angles, and alternate exterior angles. Now, there's no good way of trying to have a written way of defining this. It's actually easier just for you to see what they are and maybe define it in your own way. So, what's happened is when we've taken this parallel line and we've cut it by transversal, we've made some angles, and we're going to go ahead and label them. We're going to say angle 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, corresponding angles basically are angles that are the same. Okay? So if you look at angle 1, see its shape? That shape of angle 1 is identical to the same shape of angle 5. So some corresponding angles would be angle 1 is equal to angle 5. Now, let's look at the next one. Angle 2, its particular shape, is equal to the same thing as angle 6. It's the same type of shape. The only difference is it's kind of been moved. So we can say angle 2 is equal to angle 6. By this pattern, you should be able to figure it out by now. 3 is equal to angle 7. And then lastly, we can say angle 4 is equal to angle 8. Basically, that's your definition for corresponding angles. Angle 1 is angle 5, 2 is 6, 3 is 7, 4 is 8. All right? Now, alternate interior angles. What we have to do is look at the inside between the two parallels. All right, so we have 3. Well, 3 does not look like 5. However, if you were to put a mirror up here, 3 does look like 6 when flipped upside down. So the alternate interior angles would be 3 is equal to angle 6. And the same thing applies. 4 looks like 5 if it's flipped upside down. All right? Alternate exterior angles. So now, where before we were looking at the inside, now we're going to look at the outside. So let's look at 1. Well, 1, the alternate angle, well, it would be 8. So 1 looks like angle 8 if we flipped it upside down. Same principle. 2 looks like 7. These are your basic definitions. This is not, I could try to word this out for you better, but I feel like it's more important for you to see it. So, how does this really help us? So, why are these definitions so important? Well, let's say I give you my two parallel lines and a transversal, and I'm going to say that this angle right here, we're going to call it, we'll make it nice and easy. We're going to say 130 degrees. All right? Your job now is to find all of the remaining angles. You got to find everything else. Hey, this is where it's a walk in the park. All right, so first off, let's concentrate just on this guy right here. We know that this is a line, and basically this angle and this angle are supplementary. So we can say 150 minus 130, and we find out that this missing angle is 50 degrees. Now, let's use some of our other rules. Well, we can start using all the corresponding stuff, but let's just concentrate just on these two. Well, what does this remind you of, just this top portion? It should remind you of vertical angles, because this is a line being crossed by another line. Well, if this is 130, hey, guess what? That's 130. And if this is 130, guess what this is? Well, it's going to be 50. Okay? You just found out your vertical angles from here to here. Now, how are we going to find this part? Corresponding angles. Whatever was here, hey, I'm just going to transfer it down here. 50, 130, 130, 50. You've just done it. Just that simple. What I want to do now is to take all that information that I just attempted to cram into your brain and more than likely gave you a headache in doing so, and applying it to a problem. Alright, so we have a weird looking shape right here and various angles a part of it, and our job is to find the angle DBA, angle GBE, and angle FBE. Now, this is my suggestion. Before you even start trying to find these angles, look at the picture first. Just look at each individual piece and then start worrying about this guy later. So let's look at it. We know two things right off the bat. This is 90 degrees and this is 50 degrees. Well, if we look at it, look, we have a 90-degree angle and it's being made by two lines that are perpendicular to one another. Well, if we concentrated just on those two lines from here to here and here to here, what do you notice it makes? It makes vertical angles. Therefore, we know that if this is 90 degrees, hey, wait a minute, this angle right here is also 90 degrees. All right, cool. Well, let's look at the 50. Well, notice how this is a line here and this is a line here, and it also makes vertical angles. Therefore, we can say, hey, if this is 50, so is this. All right, so far so good. Now, wait a minute. We got two angles that are missing, this one and this one. Well, the one thing that we should be able to see right off the bat is these two are vertical angles. So whatever I get here, it's going to be the same thing here. All right, so let's find out how to do it. Wait a minute. Think this through. If from here to here is 90 degrees, what do you think it is from here all the way here? Well, it's also 90 degrees. So from FBA, if that's 90 degrees, and I'm going to draw this all on the outside just so you can see it. If that's 90 degrees, we can say, wait a minute, 50, well, what's the complementary angle of 50? Well, it's 40. 40 plus 50 equals my 90. Hey, that's cool. And if that's 40, that means this guy is also 40. Whoa! I just found all the different angles. Because of that, hey, let's go back and look at our actual question. Angle DBA. DBA. Well, that's 40 degrees. Aha! Done. All right, cool. GBE. GBE. Hey, that's 50 degrees. Haha! Done. Yes! Next one. FBE. FBE. Uh-oh. FBE. That consists of this area right here. Sorry, I don't have another color for you. But that's, wait a minute, that's not so bad because it's this angle, which is 90, and this angle, which is 40, and since they are adjacent, we can combine them and say FBE is 130 degrees. Man, I'm good. All right. All right, so here's our next problem. We're being asked to find out what angles 3, 4, and 5 are. So before we even start worrying about that, let's look at what we know. A couple of things. We know that this angle right here is 132 degrees. We also know right now that angle 1 is equal to angle 2. You know that information. All right, so let's go ahead and do some easy stuff. Well, look at this. Angle 1 and the 132 degrees are supplementary angles. So I can subtract. 180 minus 132 is going to give me 48 degrees. Alright, so we know angle 1 is 48 degrees. Well, if that's the case, that means that, hey, angle 2 is 48 degrees because that's what I've told you. Alright, so that's 48 degrees as well. Well, what's this look like? Hey, 2 and 4, that's off, these two are on vertical angles. Hey, that must be 48 degrees. Cool. Wait a minute now. If this is 48 degrees, and 2 and 3 are supplementary angles of one another, that means that angle 3 is 132 degrees. Cool. Wait a minute. 3 and 5, they're vertical angles. Hey, they're the same thing. Awesome. So let's plug it in. I found out 3 is 132 degrees, 4 is 48 degrees, and 5 is 132 degrees. How easy is that? Easy peasy, lemon squeezy. Wow. This problem escalated quickly. When you look at this problem, you don't need to be freaking out, okay? Don't rage out on me. Think about this calmly. So, I've asked you in this problem to find B, D, and F, ABE, and DEB, as well as ADE. Before you even start worrying about this stuff, I want you to concentrate just on the triangle, okay? I want you to see if you can find each individual angle and what they're worth. Once you do that, then start worrying about these angles, okay? Concentrate on just each piece. So what I want to get you to do now is I want you to try this one on your own. All right? Use all the little skill sets that we've talked about and pause the video, and when you're done, unpause it and we'll talk about it. All right, so like I said, before we even start worrying about all this, let's concentrate just on each individual piece and angles. All right, so first off, what do you know? We got a large triangle, okay? We have a really large triangle. We know this guy is 44 degrees and this one is 90. So we can actually figure out what this piece is. Remember back in last module I told you that a triangle always has 180 degrees? Well, we can figure this out. If we know that this is 90 and this is 44, we can find the missing piece. Well, what we do is we're going to say 180 minus the 90 minus the 44, and we get that this angle here is 46 degrees. All right, so far so good. Now, let's look at another triangle that we know. We know this to be 44, this is 90, and so this angle happens to be 46 degrees. Okay? Now, we've got a couple more angles left. All right? We have this missing piece right here. So if we know that this is 90 and this is 46, which we found out earlier, we can say, hey, 180 minus 90 minus 46, guess what we get? 44 degrees. So far, so good. Okay, now let's look at this. We have a straight line going here. We know that this angle here is 44, and this angle here is 46. That means that this whole piece, going from, I'm going to do a little dotted line here, going from all the way around here should be 180. How do we know that? Because a straight line always has 180 degrees. In doing so, we can say 180 minus 44 minus 46. And what do we get? We find out that this angle is also a 90-degree angle. All right? So, let's go from some other pieces. What else do we know? We've got to find out this guy, this guy, and this guy, and this guy. Well, this might be a little bit tougher. All right? Mostly, we're probably going to be sure that we're going to end up being 44 and 46. We just got to figure out which is which. All right, so let's look at this thing. Notice that this line is parallel to this line. And on top of that, we have a line here. Well, what's that look like? It looks like a transversal. So line ABC is actually the transversal of ADC and BE. So what's that telling us? This angle is a corresponding angle to this guy, 44 degrees. Well, that means if this is 44 and this is 90, this guy's got to be 46. And since this is 90 and this is 44, this whole piece is 180, we can say that this is 46. And that means that since this is now a triangle, we can say that this last piece is 44 degrees. Now the hardest piece about it was this middle section. However, we solved it using corresponding angles, transversals, and everything that was in our bag of tricks to solve for this. Now, let's actually look at the questions. BDF, all right? So B, D, F. I want from here to here. Well, I know this is 90 and this is 44, and they're adjacent angles, and they make BDF. So when I add those together, I get 90 plus 144, and I get 134 degrees. ABE. ABE. So I know that this angle is 90, this angle is 46, and since they are adjacent, we can add them. So 90 plus 46 gives me 136 degrees. DEB. DEB, well, I've already got it. DEB is just 44 degrees. ADE, so AD and E. Well, there's 46, there's my 90, and since they are adjacent, we know that they add up to be 136 degrees. Now, I will tell you this as a fact. You're going to see this one again. So, I know it is in your homework, so I suggest that you practice this one. I suggest that you come talk to me about this one. You will see it probably on a quiz. Hint, hint, nudge, nudge. And you will probably also see this on your next test. Hint, hint, nudge, nudge. This is a very important skill because it's taken everything we've just covered and rolled it into one giant package. Our next topic is what we call corresponding segments. And they occur when more than two parallel lines are crossed by two transversals. So I have three parallel lines here, and they're being crossed by two transversals. When this situation happens, we're able to set up something, a really nice proportion. And we can say that A over B is equal to C over D. Now, what does this mean? It basically means this. If I know these two pieces, or excuse me, let's start with the bottom. If I know these two pieces, and I know this piece, but I'm trying to find X, I can do it. All right? How does this happen? Well, think back to grade school. You may remember something like this. When you're talking about proportions, what's on top stays on top. Well, same rule applies. What's on top here? We have 6.5 and X. So we're going to replace the A and C. What's on top stays on top. So since they are on top, they are my numerators on both sides of my proportion. Well, since this is on bottom, what's on bottom stays on bottom. Well, they're going to be my denominators. Now look at this. Notice how 6.5 is connected directly vertically to 5.65. Same principle. 6.5 connects to 5.65. At this point in time, you should be able to solve this. However, let's just go ahead and do it together. This is basically cross multiplication and division. Solve for X, however you want to call it. So this is what we're going to do. We're going to multiply 6.5 times 7.5. When we do, we get 50.375 is equal to, all right, so we just did this piece of our cross multiplication. Now we're going to cross multiply the 5.65 times X, and I get 5.65X. Well, what do we do now? We divide by the 5.65, and we get, and I'm going to round to the nearest tenth, we find out that X is equal to 8.9, and lastly, what's my unit? 8.9 feet. And we're done. So the remainder of this video, we're going to talk about triangles now. First rule about triangles and knowing what there are. Professor David, how many sides does a triangle have?
1, 2, 3.
Are you sure? All right. Well, if my 2.5-year-old knows that there are 3 sides to a triangle, you should by now. That's the big rule. All right. Also, we've talked about this multiple times. A triangle has 180 degrees. All right. There are several different types of triangles that you're going to start seeing flashing on your screen right now. The first one is scalene. It's when each side is different and each angle is different. The next one is isosceles, where 2 sides are the same and 2 angles are the same. Equilateral triangle. Each side is the same and each angle is 60 degrees. And then right triangle. One angle is 90 degrees and the side opposite the right angle is called the hypotenuse. The remaining sides are called legs. Now, let's go back to classroom. I'm not going to spend any time on those definitions. If you need to, rewind it a little bit, pause it so you can copy it down in your notes. But by this time in life, I feel confident that you should know those. However, let's just go ahead and talk about it. Some more things. Some of angles of a triangle. No matter what type of triangle you're going to get, it doesn't matter if it's a scalene, it doesn't matter if it's a isosceles, whatever. Every time you add up all the angles, it will be 180 degrees. So make sure we understand that. You've got some examples in your notes. Try those on your own. Okay, try those. I'm not spending any time on that. You can solve for X. Okay, so do those for me. All right. Perimeter. Okay. Mr. Lewis has another pet peeve. You're going to hear about a lot of pet peeves in my class. This is one of them. If you have a problem that tells you to solve the perimeter, here is the basic definition.
Add all sides.
All right, let me say that again.
Add all sides.
If you have 3 sides, you add each individual side. If you have 4 sides, add each individual side. It doesn't matter what shape it is, excluding circles. We'll talk about circumference later. You just simply add the sides. All right. So in your notes again, you have some problems that I want you to try. Do those on your own. I'm not even going to waste my time doing a video about those problems. Next major definition that we're going to talk about is area. Area is simply this: it's the size of an object surface. Okay, so if you have a room, the rug takes up the area of the floor. Okay, so basically I have a shape right here. I want to know how much space that this shape is taking up, or how much surface. And there's several different equations that we can use when it comes to triangles. However, I'm only going to show you 2 in this classroom. One is basically one we all know and love from grade school. Area equals 1/2 base times height. And then another one that we'll talk about in a few minutes called Hero's formula, which is sometimes. All right. So area equals 1/2 base times height. This is what you need to know. If you have a triangle and you know the base and you know the height, well, how do you identify the height? If you see a 90-degree mark like I have here, that's generally telling you, hey, this is the height of this triangle. And whatever the height is standing on, notice that it's basically on this piece right here, 7.2, well, that's the base. All right, so what we're basically going to do is plug things in, and we're going to use our handy-dandy calculator to help us out. So we want to find the area of this guy. Well, it's going to be 1/2 times my base, which is 7.2, times my height, which is 2.3, and we're going to just plug all that in and see what happens. So 1/2 times 7.2 times 2.3, and we get a weird number. We get 8.28. Now, for the sake of time, I'm going to actually have you round to the nearest tenth. So in this case, this 8 tells that 2 to go up, and so we get 8.3. Now, what is my unit? Well, we know it's going to be feet, all right, but it's not going to be just feet. It's actually going to be feet square. So remember, when you're doing area, and again, this should be somewhat familiar to you, is that area will always be feet square. Why? Because area is length and width. Okay. You've got several problems that might be in your notes like this. I'm not going to go over every one. I feel like this is feel pretty confident in this. If you're still struggling, come talk to me. However, what I do want to do is talk about Hero's formula. Hero's formula should be popping up on your screen right about now. And what you see in Hero's formula, it looks extremely complicated. Again, but like with everything that we do in this class, what looks to be hard is if you keep yourself calm and chill out, it's not as bad as you think. Hero's formula is primarily used when we do not know the height of a triangle. The only things that we do know about that triangle are just its sides. And so this formula is good for any triangle that you could come across, whether it's isosceles or equilateral or anything like that. This equation will work all the time. So let's talk about it. I'm going to let that fade away and come back to the classroom a little bit more. We have a shape. Here's our triangle. We know our sides would be 13, 18, and 25. And so our job is to find the area. Well, the first thing that we have to do is figure out what S is. Well, in order for us to do that, we have this equation. S is equal to 1/2 A plus B plus C. When we figure out what S is, we can actually substitute that into our area equation. So, let's do that. S is equal to 1/2. It doesn't really matter which one's A, which is B, which is C. No, not really. 13 plus 18 plus 25. And so when we work this out with our calculator, we have 13 plus 18 plus 25, and we multiply that by 1/2. or we basically are dividing by 2, we find out that S is equal to 28. Now that we know that, we can basically plug it into our area equation. So area is equal to the square root. Now we're going to plug it all in. S is 28. 28 minus, well, we're just going to say this is A, this is B, this is C. We're going to say 28 minus 13 times 28 minus 18 times 28 minus 25. All right, now we're going to keep working this out. We'll get 28 times 15 times 10 times 3. We're going to work everything out under the radical. So 28 times 15 times 10 times 3, and we get 12,600. Now we need to find out what the square root is. When we do, we get 112.249 and a bunch more numbers. However, in your notes, I tell you that I want you to round to the nearest tenth. So what we do. We go to our tenth spot. That 4 tells that 2 to stay the same. The other numbers become a 0, get dropped. And we ultimately get 112.2. All right, so what's our units? Well, since all these were in inches, we're going to have inches. And because this is area, it's going to be inches square. Now, Hero's formula does take some time. Be patient. Be very patient when you do this. Don't try to rush through it. Just take your time with it. And double check. Alright, this problem I want you to try on your own. I've given you a triangle with 3 sides, 14 meters, 21 meters, and 24 meters. Your job is to pause the video and I want you to solve for the area by using Hero's formula. So pause the video. When you're done, come back and check your answer. Alright, when you went to go solve this problem, the first step you should have done was find what S is. You should have got 29.5. If you did not, you need to go stop the video now and go back and recalculate because everything else went wrong. Alright, ultimately your answer was 146.2 meters square. If you got that, awesome. If you're still struggling with it, you have problems, you know where to find me. The last topic that we're going to talk about in this video is Pythagorean theorem. In your notes, I'm going to read this. It says, in a right triangle, the square of the length of the hypotenuse equals the sum of the squares of the lengths of the other 2 sides. Huh? Alright, it's a whole lot easier just to see how the equation works. A squared plus B squared equals C squared. Alright, now this is what I want you to know. I told you earlier in the video that a right triangle is very special. It has what's called a hypotenuse and it also has 2 legs. Alright, the hypotenuse is always directly opposite of the 90 degrees. So here's my 90-degree angle. That means that this guy is my hypotenuse. Alright, now hypotenuse in our equation is always C. So this side represents C, all right, and that's our hypotenuse. Now, what are A and B? Well, A and B are the other 2 sides. What's so special about them? They're connected by the 90, all right? So A and B are right here. It really doesn't matter which one we will call it, but we're going to say A and we'll say this one is B. So, A and B are connected by the 90, and opposite of that 90-degree angle is the hypotenuse, which is C. Knowing this, we can actually solve for this missing side by plugging it into our equation. So, we can say 2.5 squared plus 1.6 squared is equal to c squared. Well, I don't feel like doing this all in my head, so I'm going to use our handy dandy calculator, and I'm going to find out what 2.5 squared is. 2.5 squared plus 1.6 squared. And when we do, we get 8.81 equals c squared. Now, we don't want c squared. We want just c. So we're going to use the opposite function. So since this is squaring c, in order to get rid of a square, we have to square root it. So we square root both sides. When we do, we find out that the square root of 8.81 gives me this number. 2.96816 blah 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 equals c. Alright? I don't feel like writing all those numbers out. But what I'm going to get you to do is round this to the nearest tenth. Well, my tenth spot is right here. This 6 tells that 9 to go up. Well, it doesn't have any other place to go but up to 10. In doing so, it changes this too. So that becomes a 3.0. All these other ones become zeros, they get dropped. So our answer is 3.0 feet. So we have another right triangle here, and this is what we see. We see that this side is 9.6 meters and this side is 12.6 meters. So what side is what? Well, I told you a while ago that the 90, the sides that are connected to the 90, well, those are my legs. So we can say that this is A, and we can say that this side is B. Well, that also tells us that the 90, the line or the side directly opposite that angle, is C. So this is what I know. I know what A is and I know what C is. My problem is find B. So we're going to use the equation again. Okay? So we're going to say 9.6 squared plus B squared is equal to 12.6 squared. Well, I need to solve for B, so what I'm going to do is I'm going to get rid of this 9.6 squared by subtracting it on both sides. I'll rewrite this where that cancels out. B squared is equal to 12.6 squared minus 9.6 squared. So, we're going to use our handy dandy calculator to find out what 12.6 squared minus 9.6 squared is. So, 12.6 squared minus 9.6 squared, and I get, evil number, didn't mean that, oh well. Alright, 66.6. Well, math is evil, guys, okay? Forgive me, I'm sorry. Now, we want to know what square root of this is. So we're going to square root both sides, and we get B is equal to 8.160888 blah 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 blah. I want you to round this to the nearest tenth, which happens to be here. This 6 tells that 1 to go up, so I get B is equal to 8.2. Those zeros become zeros, and we drop them. So the answer is 8.2. What's the unit we're working with? Meters. So 8.2 meters. All right. We are actually through with this video. However, I did want to give you one little thing, more as a challenge than anything. You have a shape here. We have a triangle. I've given you the two sides, here and here, 39.4 and 88.4. Your job is to find the perimeter of this shape. Now, with that said, I'm not going to tell you what to do, I'm not going to tell you how to do it or anything like that. I think you can figure it out on your own. And so to sweeten the pot of why you should do this, on the day that these notes are due, if you have the correct answer, I'm going to add 2 points on your next test. So, 39.4 centimeters, 88.4 centimeters on this side, find the total perimeter altogether. That is your job. I'll leave this here. Now remember, if you're having any problems, come talk to me. You know how to find me. See you in the next video.